Today we're going to look at factoring expressions with variable exponents. An example of an expression that has variable exponents would be x to the 2a plus 2x to the a plus 1. Notice our exponents have the variable in them of a. To factor this, we're going to look at it just like we would a quadratic. I'm going to ask myself, what two things will multiply to give me x to 2a? And in this case, it's going to be x to the a and x to the a. Remember, when we multiply, we add the exponent, so a plus a gives us that 2a. Our last term has to multiply to give us 1. Well, in this case, the only way we can do that is a 1 and a 1. Remember, when we multiply the two inside and also the two outside and add those together, so here we get 1x to the a, multiplying the outsides, we get 1x to the a. When I add those two together, it's got to give me that middle term. So in order to give me a positive 2x to the a, both of these terms will have to be positive. And there's going to be my final answer. X to the a plus 1 times x to the a plus 1. We could also write this as x to the a plus 1 squared. Now, a couple of things that you should notice, and that I'll bring to your attention. Notice the exponents are 2a and a. In order for this to be factorable as a quadratic, we'll always have that 2 to 1 ratio. So if I take 2a to a and reduce that, I end up with a 2 to 1 ratio. Another thing that you can notice is that this term, x to the a, will always be what we have here, except for if we had a number in front of here. So if this was like 2x to the 2a, one of these would have to be a 2x to the a. And we'll look at that a little later on. Let's go ahead and look at another example, example 2. And we'll pull that variable, or that constant, into the front. So we have 3x to the 4n plus 5x to the 2n plus 2. Notice we have that 2 to 1 ratio, 4n to 2n. So it's going to factor like a quadratic did before. If I look at 3x to the 4n, the only way we can break that up would be 3x to the 2n and x to the 2n. We're going to break up our 2. The only way we can break up 2 would be 1 and 2. But remember, we have to work with that 3 in order to get that 5 in our middle term. So I could put my 1 here and my 2 here, or my 2 in the first quantity and my 1 in the second. The only way we're going to get that 5 being positive would be a 2 in the first and a 1 in the second quantity. Both of these terms will be positive. Checking my math, I have 2x to the 2n, and I multiply my last two, or my outside two numbers, I get 3x to the 2n. Adding those two together gives me the positive 5x to the 2n. And that completes that factorization. In example 3, let's look at x to the 4a minus y to the 4a. Notice on this one, we don't have a 2 to 1 ratio. We also don't have 3 terms. But if I think about 4a and 4a, those are perfect squares. So this case is going to allow us to factor it with a difference of perfect squares. And we have x to the 2a, x to the 2a. To get y to the 4a, we have y to the 2a and y to the 2a. And in order for those two to cancel out that middle term, one's going to be positive, one's going to be negative. But if we look at x to the 2a minus y to the 2a, those are both perfect squares. So we have x to the 2a plus y to the 2a, which comes down. And then our last quantity there is going to factor as x to the a minus y to the a and x to the a plus y to the a. Remember, one term has to be positive and one has to be negative in order to cancel out that middle term. And that would be another example of a similar to quadratics, but doesn't have that middle term. Let's go ahead and look at one more example. Example 4. Excuse me. In example 4, we're going to take a little more complicated problem, just because we're going to change that exponent slightly. But we're still going to see that we have that 2-to-1 ratio. So it's going to factor similar to what a quadratic would factor to. So we're going to start by looking at that first term, 10x to the 4a plus 2. There's a couple of ways that we can factor that. We can do 5 and 2 or 1 and 10. But if I look at my positive 3, that positive 3 can only be broken up in one way, and that would be 3 and 1. So now I can think about breaking up my 10. 10, we have, remember, 2 and 5 and 10 and 1. Working with that 3, I'm going to multiply the 3 by one of them, add it to the other to give me that middle term of 13. Well, if we have 10 x to the 2a plus 1 and x to the 2a plus 1, to get our middle term to be negative, both these terms will have to be negative in order to get the positive 3 when we multiply the last terms together, and get a negative 13 when we add these two products together. So here we have negative 3x to the 2a plus 1, and here you have negative 10x to the 2a plus 1. Adding those two together gives us that negative 13. Notice again, my exponent for my first term is always going to be what I started with as my middle term's exponent. And we'll always have that 2-to-1 ratio. If I look at 4a plus 2 and 2a plus 1, this is twice as much as my second one. So to recap, factoring expressions with variable exponents, we're going to factor them very similar to what we did with quadratics, as long as they had a 2-to-1 ratio.